To solve this problem, we need to find the critical points where the function is increasing and or decreasing, and the extrema, and say if this is a maximum or a minimum, and don't forget to put it in ordered pair form. To find all of these things, we use our first derivative. So let's take the derivative. If you notice, this function is a quotient. We have a top and a bottom, and the x is in the bottom. Now you can either change this to make it a chain rule, which I know that we're struggling with right now, so we'll do quotient rule. So to find the derivative, we have low d high, the derivative of 3 is 0, minus high d low, the derivative of the bottom is 2x. All over, don't forget the bottom, x squared plus 4 squared. We can simplify this. 0 times anything is 0, so this is gone. And we have 3 times 2x, and then the negative of that, so 3 times 2x is 6x. So we have negative 6x over x squared plus 4 all squared. Okay. Now, our critical points happen where our derivative is either 0 or undefined. Our derivative is 0 when the top is equal to 0, and our derivative is undefined when the bottom is equal to 0. So let's look at both of these things. We need negative 6x equal to 0 and x squared plus 4 squared equal to 0. Here we would just divide by negative 6 and x equals 0. Over here we would take a square root. We get x plus 4, square root of 0 is 0. We would subtract 4, we get x squared equals negative 4. And when we take the square root, look at this. We are trying to take the square root of a negative number. Now, we do not have imaginary numbers on our x and y coordinate, so we cannot have that in our function. So this does not give us any information that is useful in this context. So because we cannot take a square root of a negative and get a real number, this does not matter. It does not give us helpful information in this context, so we're done. We only have one, oh goodness, my computer. We only have one critical number. Our one critical number is x equals 0. Here's our critical number. Okay, so first part of this problem, check. Now we just have to find increasing and decreasing and the extrema. So to find that, we put this 0 on our number line. And we are only going to have two sides to check, so we need something bigger than 0 and smaller than 0. So let's do negative 1 and 1. Be careful that you're not getting your numbers that you're testing in your first derivative test mixed up with your critical numbers. I would suggest putting the numbers that you're going to test on top and circling them and leaving your critical numbers alone on the bottom. You do not want to get those mixed up because your test numbers are going to go into your derivative to test the sign, and your critical number will eventually, if it is a minimum or a maximum, is going to go back into your original function. So let's plug negative 1 and 1 into our derivative. If we look here, and my computer is acting up again, sorry about that. Let's go back up. If we look here, we have negative 6x over x squared plus 4 squared. And we're plugging in negative 1. So negative 1 would give us negative 6 times negative 1 over negative 1 squared plus 4 all squared. So on the bottom, this is going to be a positive number. On the top, it's going to be a positive number. So we are increasing or positive over here. Our derivative is positive. Now, if we had changed that to a positive 1, the bottom would still be positive, but the top would be negative. So we have a negative over here. So our function is increasing to the left of 0 and decreasing to the right. So we can say some intervals. Our increasing interval starts at negative infinity and stops at 0. And our decreasing interval starts at 0 and goes to positive infinity. Then we need to see if we change signs and we have a maximum or minimum. We go from a positive derivative to a negative derivative. That is where we would have a maximum on our original function. And we already know our maximum x value is 0. We just need to find the y value. And it is okay that we have no minimum. We have no relative minimum here. So let's get our x value. We take 0 and we plug it back in all the way up here. Let's get rid of that line. When we plug it in up here, we would get 3 over 0 squared plus 4. So we have 3 over 4. So that is our y value that we will take and plug in down here. There's our maximum, 0 and 3/4. And we have answered all the parts of the problem, so we are done.